My name is Bill Hildebrand, and I work for a company called The Platform. And we specialize in online media distribution and publication. And today I'm going to talk about applied partitioning. So we're obviously talking about MySQL 5.1 and how we can apply that to OLTP systems. So we're going to go over sort of the classic use of partitioning. Normally think of data warehouses when we think of partitioning. And then look at applying partitioning to OLTP applications in general. And then take a look at a specific type of partitioning called hash partitioning and look at a few implementation examples. And so hopefully you can take away from this the ability to go back and quickly look at your OLTP database and have a good idea of how to apply MySQL partitioning to it in a quick, effective way. So when we think about partitioning, normally we think about data warehouses. And back in the day, the old school way was essentially, data aged out, so you'd create another table, call it the archive table, dump data into it, and then if someone ever needed to look at that data, you just do a union, and union that data in, and it gave you a few advantages. You could put it on slower disk, maybe even off to backup and bring it off of tape if it was needed, different things like that. And then you got a little advantage because most of your queries only use the smaller tables with the most recent data. So that worked for a little while, and then a lot of the database vendors came out with automated partitioning, and the optimizer knew about that partitioning. So we as DBAs didn't need to create a bunch of archive tables and all that stuff. We just tell the database, hey, go create us some partitions. And even better, the optimizer knew about them. So when we loaded data into them, it would only insert into that partition. And we didn't have to write any logic. The database took care of it for us. And that's sort of the history there. And it worked with data warehouses great because, usually in the data warehouses early on, everybody was looking at data information. So how do we do last week, last month? How are our quarterlies doing? And as things got older last year and the year before, we didn't really look at that data that often. And so partitioning was great for it. You just do your range partitions, partition by quarter or whatever. And we also had fairly predictable growth patterns because you're aggregating lots of data. So you knew, yeah, we're going to load in about 10 million rows a day or 100 million rows a day. And so you could set up your partitions ahead of time. You knew about how many you need to cover the next month, quarter, year. So it's great for data warehouses. And some of the benefits we talked a little bit about, query performance obviously, because the optimizer knew I'm only getting data from this partition, so don't even look at those other partitions. And there was also some maintenance benefits. I could load data into a specific partition without affecting any of the other partitions. And so that's where partitioning came about, from the need to kind of archive out data that we don't use that often. So when we talk about applying partitioning to OLTP, there are a couple different things that come into play. Normally we're not, or in a lot of our applications anyway, we're not date driven. So we're not so concerned about what did I just do? What did I do last month? We're accessing our data by, say, user ID. Give me all the data associated with this user, or give me all the data associated with this customer. And so that's one thing we got to think about as far as when we apply partitioning. The other thing is, as far as estimating the growth rate and partition sizes. A lot of times we don't know tomorrow how many rows we're going to be loading in. Especially today when you talk about the socialization networks and things like that. You know, get on Google and all of a sudden you have 20 times as many users and things like that. So your growth ranges can be a lot different. And then a lot of times in our OLTP systems we have intelligent keys. So we have things like customer ID, which say we have 20 customers, 2 of those customers comprise 80% of our data. That we might need to take that into account when we partition based on customer ID versus when they loaded that data in by date. And then we also have operational issues. Data warehouses, usually it's your business users. They're 9 to 5, you know, working at the bank, go and look at our financial data. And so we can load millions and millions of rows at night. Who cares if it locks up all the tables? Who cares if we have to rebuild a bunch of indexes? Doesn't matter because everybody's at home. Yeah, there's a couple people, you know, VPN'd in looking at stuff. But we can't do that when we're talking about our online databases because half the people are going online when they get home from work. And so it's harder to schedule downtime for things like DDL changes, index rebuilds, things like that. So as far as benefits with partitioning and OLTP, they're very similar to what the data warehouse work gets to with partitioning. The first one is, you reduce your seek and your scan set sizes. So now instead of, if I have to do a scan for a username, I'm only going through one partition that maybe has 1 million rows rather than the whole table that has 10 million rows. And so that reduces seek times, it reduces pages that you have to pull off disk and memory and all those. And then even when you think about order buys and sorting, you reduce your sets, you're doing those kind of operations. You also limit your insert and update transaction durations. So if I'm going to insert a row into a B tree, it's only the B tree for that specific partition instead of the one for the whole table. And so there's benefits there as well. And it also gives us some more additional options for how we do maintenance. So in the case where we have all our data by customers, and you know that 2 of your 20 customers, if all their data is in separate partitions, then I can do maintenance for one customer at a time, and which can help with planning when you're going to do maintenance, how long maintenance might take for a specific customer versus the whole thing. And so maintenance can definitely be improved by using partitions on OLTP systems as well. So here's just an example of how partitioning would reduce your scan and seek sizes. And this is just a very simple employee store relationship here. But you can see in the top example, and you might not be able to see in the back, that it's an explain plan. And we have a store that has about 50, there's 50 stores in the store table, and I think about 50,000 rows in the employee table. And the top one is a non-partition table, so it's doing a scan. Obviously there's no partitions in the employee table, and it's going to, they're estimating about 50,000 rows we're going to do the scan on. And then down below we partition the table, the employee table, and give it 50 partitions. And you can see when we do the scan, we're only going to scan partitions 5, 8, and 10. And the estimate is down to 3,000 rows now. So when you translate that out into what that actually happens, this is just a MySQL slap of that same query. And you see this is without the partitions. So we have the average number of seconds, about 141 milliseconds to run each query. And then the overall time was 2 minutes, just a little over 2 minutes. And then the same query with partitions, you see the average seconds to run a query drops down to 6 milliseconds. And our actual time is about 6 seconds. So it's a pretty good bang for the buck on an OLTP application as well. And this was just running pretty simple select. So when we talk about being able to do the advantages with respect to maintenance, if we want to optimize our table without partitions, we basically have to, just optimize the whole table. Within ODB, you're going to end up creating a new table, because essentially an alter table. So we run that on the employee table without partitions, 1.14 seconds. And then, but if we have a partition, we can just rebuild a specific partition. So now we just rebuild the one partition, 0.03 seconds, and we could actually partition, in the second example, we do 10.27 seconds. So the overall time to partition to rebuild all the partitions might still take 1.14 seconds. It'll probably take a little longer. But the advantage is, if that were by customer, then I could just rebuild one customer at a time, and the downtime for that one customer would be less. So those are some of the advantages you get from a maintenance perspective if you have partitioning on your OLTP databases. So now that we're all going to upgrade to MySQL 5.1, we can start applying partitioning to our databases. And we definitely want to think about some different things because there's 4 different types of partitioning, 5 if you count sub-partitioning. So there's lots of different ways we could do it. And these are a couple of things that I like to use when I'm looking at, okay, here's my application, here's the different things that I want to look at for deciding what type of partitioning I should use. So the first thing, somewhat obvious, is size, right? I'm going to go after the biggest bang for the buck. So if I got a table that's 10 million rows, that might be screaming, hey, maybe I should partition this table. As well, predicted growth patterns. I might have a new functionality coming out that adds 3 new tables, and I happen to know that over the next 2 months it's going to grow to 1 million rows. Then I might want to look at partitioning that before it grows to 1 million rows, even though the size today is really small. So those are a couple things. Access patterns is probably the next thing. So I have a date key and a customer ID in my table. What should I use to partition on? Well, if 80% of my queries are by customer, then it probably makes sense to look at partitioning by customer versus date, even if the customers are looking at the most recent data. So things like that, you want to grab something that covers most of your access patterns. And then keys and indexes. There are a few restrictions with respect to partitioning around keys and indexes, and obviously foreign keys aren't supported currently on a partition table. So things like that you'll want to look at. There's some other restrictions around whether or not you can partition on a column if it's not part of your primary key. So things like that you got to consider when you're going to apply partitioning. And then availability requirements. So where I was talking before about customer data, and some customers maybe have different SLAs for different customers. So that might be a case where you might want to do a list partition or something where you put certain customers in different partitions because they have a higher availability, so you want to be able to just do maintenance on theirs, where others, they don't, and we can do, reorg 20 partitions at one time, and it's no big deal because they only have 9 to 5 support, something like that. And then manageability considerations is really more along the lines of human resources. So I don't remember if it was YouTube or one of those were saying they had 3 DBAs. So I wouldn't be super excited about being a DBA there and then finding out I needed to partition all my tables and make sure they were all partitioned on all the different instances, and that might be a lot of work. So, but I might look at a hash partition in that case, where I don't have to do a whole lot of management. Whereas a list partition might take a lot more thinking and thought and planning into where we're partitioning. So manageability from a human resources perspective is something to think about. And then reuse scope. When I'm talking about reuse, I'm talking about, can we apply this same partitioning scheme to many of our tables? So if I partition by customer in this table in my OLTP database, but I don't partition by customer in any of my other tables in the same database, that may not make sense. It might be better to partition it by user ID if most of my joins are associated with user ID versus customer ID. And that'll give me advantages when I join to the other tables and just looking at those similar partitions. So those are some of the things to think about when we're going to apply it to an existing database that you've already got out there. So now let's talk about the different types of partitioning. There's 4, I consider 4, there's 5 if you include sub-partitioning. So we have range partitioning, list partitioning, hash partitioning, and key partitioning. And sub-partitioning allows you to take a range or list partition and then apply a hash or key partition underneath it. So sort of create a bunch of partitions under each range or under each list. And when we look at range partitioning, that's the classic data warehouse type partitioning. So if you have data that's accessed by date a lot, most recent, say an order entry system, and you're always looking at the most recent orders, that might be one where you want to look at range partitioning. Some of the things you want to think about, though, is I have up there a limited number of primary partitions needed. When you're creating a range partition, you have to define what those ranges are. So if you're going to have 1,000 ranges, every time you have to type that out, write it out, you have to define those ranges. So I personally like to keep range partitions to a key that allows me just a few ranges. And then it works best with, if you're talking about intelligent keys, an ordered intelligent key. So, because say customer ID, and you have 50 customers, if you need that to be intelligent, that I know what customer 1 through 10 are, then you want it to be arranged because you're going to say, oh, customers 1 through 10 go in this partition, 10 through 20 go in this partition, and if you want to know about that, then you want it ordered because it's going to be arranged. And but it does have an advantage that it supports a sub-partition. So you can create a few partitions up on top and then just hash underneath. And so that's how you can get your, say 10 partitions, but then get another 20 partitions per partition. A little confused. So a list partition, if you have data that needs to be grouped out of order. So in our system, we have a few customers that are high use, they have lots of data, and they have very high uptime requirements. And then we have hundreds of customers that, they use the system once in a while, they have a few thousand rows, nothing big. So, but the only problem is it's an auto increment ID, right? So our customer ID wasn't really in any order. So our big customers are, and this is not in actuality, but say our big customers are, our little customers are 1, 5, and 7, and our big customers are 2 and 8. Well, that presents a problem with range partitioning because I can't just have intelligence in how it is. But if I use a list partition, now I can put my low-use customers all in one partition, 1, 5, and 7, and then I can put 2 in its own partition and 8 in its own partition. And now I don't have to worry about all the crazy inserts and deletes that are fragmenting my table from customer X, who does 90% of all our stuff. I don't have to worry about them affecting customer Y because he's in his own partition, so he can mess up his own data and fragmentation. So that's the key place where I would think about using list partitioning is when I want to partition my data, but not in any kind of order. I want to do it out of order. So, and I can use sub-partitioning with lists too. So in the case of my big customer that has millions of rows, I can still throw a hash partition under that and dump him into little buckets of, 1 million rows each. So hash partitioning is my favorite because it's low maintenance. So if I get hired at YouTube and they want me to do partitioning, most likely I'm going to suggest hash partitioning. Because all I do is say, okay, I want to partition this data and I just want 50 partitions and I don't want to think about it again. And that's great from my perspective. So it's great, it's low maintenance. It actually works pretty well with limited or large amounts of partitions. So I can say, give me 300 partitions. It's still one command. It's awesome. Then in generally it's good with non-intelligent keys, so I don't really care about what bucket the data ends up in or what partition it ends up in. You can do things, since we know with MySQL that it uses modulus to throw the data into different partitions. We can use hash partitioning with some intelligence, and that's what I do in an example, and you'll see later. And then key partitioning is very similar to hash partitioning. The nice thing is MySQL converts a character to a character-based key to an integer-based value for you. So if I wanted, if my key on employee was employee name, I could partition on that, even though it has to resolve to an integer. Because MySQL basically apply, depending on the linear or nonlinear key partitioning, it'll apply some form of the password or an MD5 hash to convert to an integer. So that works great, and it's low maintenance too. You just say, tell it how many partitions you want, and that's what you get. So those are the main 4 partitions. Sub-partitions is just applying key or hash underneath the list or range partition. And you usually see that in a lot of data warehouses, the sub-partition. So my example I'm going to run through is how we could apply a hash partition to an OLTP system. And when we talk about hash partitioning, you're just applying a hash to your partitioning key. And that's how both hash and key partition types work with MySQL. And essentially you tell it, I want a fixed number of partitions, and MySQL applies a mod based on the number of partitions, and it dumps your data in that way. And you'll see that's kind of how we can use intelligence with that if we apply it right, so that we actually can know beforehand that customer X is going to end up in partition 1 or partition 7. So for our example, I have my little retail store application, and we have my store, my employee, and my inventory. So we have stores, different cities all over the world, and we have about 50,000 employees. They're all spread out fairly evenly in all our stores. And I have a bunch of inventory. And so this system kind of helps me sort of do a point-in-time delivery, so that as my stock decreases, FedEx sends over a new package and they get their stuff. So pretty basic, nothing big. I didn't use any data modeling for this. So, but I have my store ID. It's just an auto increment. And I have my store ID also in both my tables. So everything is accessed primarily by store ID. So if I have inventory, if some new inventory comes in, all the inserts, all the selects against it use store ID. So I'm going to partition my tables based on my store ID, because I know that that's how most of the data is accessed. I might do it different if it was by customer and I was tracking customer information. This system is more about tracking inventory. So I decide I'm going to do my ID for store, store ID for inventory, and store ID for employee. So because I know how many stores I have 50, I'm going to do hash partitioning, partly because I'm the only DBA and I want it to be easy as well. The one advantage I get is that now that I know I have 50 stores and all my employees are associated with the store and all my inventory is associated with the store, I can apply that same partitioning scheme across all my tables. So I apply basically with my store by hash ID, tell it how many partitions I want, do the same thing for employee, and do the same thing for inventory part. And you can see it actually does do an alter table by the times. You can see it. So obviously, when you're going to apply partitioning, if your application is already in production, there is some downtime blocking associated with it, depending on how you do your replication and that and stuff. So anyway, pretty straightforward, nothing big, easy for me, which I like.
What will you do when they have new store?
Great segue, we're going to go right into that. So, oh my gosh, we're growing. Let's expand into Australia. So we got 2 new stores. Now we're just going to add a partition. So, and actually we're going to add 2 partitions because we know beforehand we're going to add 2 stores, and I only want 1 store per partition. So I'm going to alter my table, add partitions 2, and then now I don't know if any is Brian Anchor in here. No? I'm not sure if anybody knows. You notice it says 0 rows affected. I'm not sure if that's a bug, a feature.
I think that's it.
Oh, okay. Okay, good. So it may not say 0 rows affected with my next build. Because what's actually happening here is we added 2 partitions, and I'll show you the next slide, I think. what's interesting is if I look at the information schema and look at my partition name and which partitions don't have any rows, you notice it's 0 and 51. And the reason for that is that we're using modulus to do our hash. So now that I have 52 partitions, my 52nd IDs are going to end up in partition P0, just because of how modulus. So that's the reason. And then before this, we had 50 partitions. So all the rows from partition, what would have been partition 0, are now in partition P50. So that's why I would have expected something to say about the number of rows affected, because it did actually migrate rows from one partition to another. So, but this is a way you can check that, hey, we do have 2 new partitions, there's no data in it. It's nice you can create it beforehand, because hopefully when we open the new stores, we know about it. But it could happen overnight if we got bought out, something like that. So, pretty straightforward. Information schema has a lot of stuff about partitions. And so then the next question is, what happens when you close some stores? So I don't know if they were bought out or they didn't do well or what, but 4 of our stores in China, we decided to close. And so now I'm just going to coalesce 4 partitions out. So you can see it takes a little time, but we're obviously not altering the whole table. And so what's happening is we're going from 52 partitions down to 48 partitions, and the data gets migrated over to the other partitions. And you can see here now in our information schema, there's only 48 partitions for our employee tables.
See where you specified which individual stores. How does it know which partitions it's pulling off? You simply taught it to the late 4 partitions.
Yeah, so that's a good question. That's where hash partitioning doesn't really, you can't really use it with intelligent keys unless you know how the hash works. So we know that it's using modulus, and I know that my customer IDs were auto-increment, so 1 through 50. So the 2 new ones I knew were 51 and 52. So I can't tell you what IDs the China stores were in without looking at the ID. So I don't know that because China's ID, I don't know that by the number of partitions which ID China is, but if I look at the ID for China and it's 10, then I know 10 mod 52 is whatever. I can pull out my calc and do that and find out which partition it's in. Which you would have to know if I were going to do maintenance on those 4 stores and let them know that, hey, your partition's going to be offline for a while. So that's, I cheated and I knew how many rows I had and I keep track of that. In general, if you don't care, because it's, say, user ID, and you have 50 million users, then you're not going to care. Let's just hash it out, and then you can just, when you do maintenance, it'll just be some percentage of your users. But if I have a small number, then I can actually calculate which customer is going to go offline when I rebuild this partition. Does that answer your question?
So in that scenario, would it have been better for you to use a range ID so you could specify what stores go into what partition?
Yes, if I, well, yes and no. So it depends on how I'm going to apply that range to all my tables and then how many ranges I want to write out. So in this case, so if you really want to know, yeah, ranges are what you normally use for an intelligent key. So, but if I wanted 570 partitions, That would be kind of a drag with range because I'd have to write out all 570 partitions. So in this example, you know, it's a little, yeah, you might use a range partition there too.
One problem that I see is if you have auto increment for store IDs, over time you start deleting those, and you're relying on your partition size, you might have collisions in terms of multiple stores in the same partition.
Yeah. So the point is, if we do a lot of deletes and adds, and we're doing an auto increment, then all of a sudden my cool little, oh, I know where by my hash I can control which store goes into which partition, kind of falls apart because all of a sudden my next 7 stores might be auto increment 54, auto increment 68, and 72. And so then it doesn't quite hash the way I think it's going to hash. So you are correct, yes.
How do you solve that? Like the key partitioning, does that allow you to say, make a unique partition for every period key?
No. Well, how you solve it is what's your name? Lee. What Lee suggested, you could use range partitions so that every range is one customer. You need to be careful because once you hit 1,025 customers, then you're going to have a problem because it only, or 1,026. So you could do things like that. You could use a list partition. So yeah.
It seems like that would be a really nice feature to say, create a partition for your key.
Yeah, but then you'd have to somehow limit it to if you ever had more than 1,000 keys because we're limited on that. That would be the drawback to it.
So to follow along on that, let's say I had used a range and the range was 1, and I closed my 4 China stores, and their IDs are 21, 22, 23, and 24. So I want to delete those 4 in the middle. And now, or if I just say delete those 4 partitions, pull them off the end, or how would that work?
Well, you would modify your ranges. So you would coalesce your ranges and essentially change your ranges. So so if you deleted,
We can reorganize
yeah. So then you would just include that. So if you had now you have 48 and 49, you would reorganize that partition to be where values less than 49, whereas before it was 2 partitions, value less than 48 and value less than 49. So you would reorganize that into 1 partition that was values less than 49.
So now I see why you like to hash.
Yeah, yeah. Because I'm lazy and I like to be lazy.
Is it possible to create like deleted stores database and move that and that partition for there? Like move it to different database and not steal from present one.
Not sure I
Okay, you
understand.
have database active stores and you have database.
Oh, so 2 partitions where 1 store, my store is active and 1 my store is deleted?
Right. So you just instead of redistributing inside of the rest of partition, just move partition elsewhere. Is it possible?
You move partitions between
Oh,
databases.
no, I don't believe you can. You'd have to create the table again in the other database.
Okay, yeah.
So, yes and no. Not automatically. I can't say alter database, move table.
Not yet.
Not yet. Okay, so we'll look at a few more stats. What's that? Oh, okay. Back and back.
On the key-based partitioning, is it unique keys only, or do you have multi-keys?
You can have multi-key. You can have multi-columns in your key partition.
Non-unique.
Non-unique. It has to be part of the primary key, so it must be unique. Well, it has to be part of the primary key. So I don't know that that means it has to be unique. Because you can use a column of your primary key, but not every column of your primary key, which implies it doesn't really have to be unique. Am I right? Yeah. Okay. All right, so just 2 more slides. This is just to show you, now I'm going to do a 3-way join on a lot, and it'll show you how quickly it goes. So, and you won't be able to read any of this, but it's basically doing a 3-way join with some random in it to force a scan. And you can see without partitions, on my employee with no partitions, I'm going to scan through about 4,000 rows and about 500,000 rows on my inventory. And when I actually do this, like, it's going to take 16 seconds. Now, with my partitions, you see I'm only going to hit the 5 partitions, 5, 8, 10, 23, and 80. And I just reduced my employee scan down to 94 rows, estimated 94 rows, and my inventory down to about 50,000 rows. And you can see I'm down to 1.8 seconds. So this is great for any of your OLTP systems. And so if you want a few things to take away, it's an easy way to scale within a database. Not outside a database, but within a database. It does have a place in OLTP. Please use it there. Remember your access methods and maintenance when you think about why you might want to partition. And range list for intelligent partitioning, if you want to know about the data and where it ends up. And hash key for low maintenance, lots of partitions. So I think it's 12:40 now. So I'm here for questions. Feel free to leave. And this will be available online with my notes as well.